right, here we go. Video 2 for our math review. We're picking up at power in a requested meridian. Let's do 2 of these. We're going to do number 12. So we've got -2, -150 at 45. They want to know what it is at 90. Step 1, remember, how far away is our given from our requested? I'm going to grab that calculator. 90 minus 45 equals 45. So we're 45 degrees away. That's going to give us our 50% of the cylinder. So half of our -150. So you go 1.50 times 0.50 equals 0.75. So minus 0.75 is the 50% of our cylinder, and then we're adding that to the sphere. We've got 2 minuses. We're just going to add those guys together. So we're going to do our 75 plus our 2. That equals 275. So our answer minus 2.75 at the axis of 90. So that was number 12. Let's go ahead and tackle 15. So 15 basically says that the prescription Plano -50 at 30. So Plano -50 at 30. They want to know what it is at 30. Now remember, 0 degrees equals 0%. So that means we're not using any of the cylinder. That -1/2. Plano then becomes the answer. As we look at a prescription, whatever our given axis is, the sphere power is the power at that axis when none of the cylinder is in effect. So the answer here is Plano at 30. Let's go ahead and do horizontal prism as well. So I'll get rid of this guy here. Take a look. We've got our patient's a -4, -1/2 at 90. And we have a PD of 65 and an optical center placed at 70. Step 1 in this equation, because we are talking about horizontal prism, we need to know our power at 180. Anything horizontal requires the power at 180, and in this case then we're 90 degrees away. So 100% of our cylinder applies in this equation. So we're using all of our half of a diopter added to our sphere. So we're doing 4 plus 1/2 equals 450. 450 then becomes the power in our Prentice rule. So power times displacement divided by 10. Our displacement here is just the difference between our PD and our optical center. That's 5 millimeters. That we're going to plug into our Prentice rule, and then we're going to go ahead and do the math on the calculator. So 4.5 times 5 divided by 10. So do 4.5 times 5 equals 22.5 divided by 10 gives us 2.25. So this particular error created 2.25 diopters of prism. We're not quite done yet. We do have to tackle base direction. And remember that pluses are the same as what was wrong, and minuses are opposite. In this particular scenario, we asked for a PD of 65, but they sent us glasses made with the optical center at 70. So they made it wider or out further than they were supposed to. This prescription was a minus prescription, so we want the opposite direction as how these glasses were made incorrectly. So the opposite of out would be base in. This particular error with our patient's -4, -1/2 at 90 prescription of making the glasses 5 millimeters too wide created 2.25 diopters of base in Prism. Definitely too much, definitely requires a remake. There we go, requested Meridian and horizontal Prism. I think we've got enough time in this video to go ahead and tackle our vertical imbalance question. Let's get a clear screen here and dive in. This particular patient's right eye has a prescription of -150, -2 at 135. Their left eye is a -0.5, -25 at 88. Now, in this particular equation, they've given us a reading level of 10 millimeters. Basically just says that as you travel from the distance prescription down into the reading segment, our patient had to travel 10 millimeters to get there. They would like to know then, based on the fact that our patient's prescription is quite a bit different, how much imbalance is being created by this difference in prescription. So how much slab off is going to be required to fix that, and then in which eye does that slab off belong? Now, anytime we're talking about vertical or movement into the reading area, because we're traveling vertically down in the lens, we need to know what the power of our lenses are at 90. As we look at the right eye, we can see that the difference between our given and requested meridian is 45 degrees. 45 degrees equals 50% of our cylinder. So half of this -2. So we can do 2 times 0.50 equals 1. So we're going to take our -1, which was the half, combine that with our sphere, and we end up with the right eye being a -250. Now we've got to tackle our left eye. Difference here is only 2 degrees, which means the closest percentage is actually 0. So not using any of that -1/4, leaving our left eye with a -50 at 90. Now that we know the difference between the right and left eye, we can figure out how far these lenses are imbalanced. We've got 2 minuses here, so we want to think about this kind of like on our number line. If I was traveling from a -250 to a -0.5, and let's say Plano is sitting here, how far did we travel to get from -250 to -50? In this particular case, it's just like when you're neutralizing a pair of glasses, that difference on the power wheel. In this particular case, we would actually be traveling 2 diopters. So the slab off required to correct this imbalance is actually a 2 diopter slab off. Now we just have to figure out which eye it belongs in. We always put slab off in the least plus or the most minus. And as we look at these two lenses, this right side is definitely the most minus, so we would be prescribing 2 diopters of slab off for this patient in their right eye. Now, this particular equation, we're doing Prentice rule. However, because of the fact that our reading level is at 10 millimeters, if we were to plug this 2 diopters of Prism or imbalance into that equation, 2 times 10 divided by 10, it would actually just equal 2, which is why I kind of skipped that step in this one. Now, if they gave you something other than a reading level of 10, you would for sure want to go ahead and plug this information into Prentice rule so that we could, determine how much that movement created imbalance, and then in turn prescribe the correct amount of slab off. However, most of the time ABO is going to use that rule of 10 millimeter reading level, so we should be able to forego this Prentice rule step and just prescribe that difference in imbalance for our patient's lens. Thanks for joining me for Requested Meridian and Prism. Join me for our next video to wrap up our math quiz. Thanks, guys.